All right, we're doing 2-3 two-dimensional figures, and we are going to be learning about perimeters, circumferences, and areas, probably something you have done possibly in the past, so we're just going to be brushing up and calculating the measures of real-world objects. So, looking at your notes, we'll be filling in some blanks here and then doing some practice. So, I'm going to highlight some of those fill in the blanks. A polygon is a closed plane figure. That means it's all of the ends are enclosed with at least 3 straight sides. Okay. The perimeter of the polygon is the sum of the lengths of the sides of the polygon. Some shapes have special formulas for perimeter, but all are derived from the basic definition of perimeter. And one of those that has a special formula for perimeter is this very next one, circumference. Circumference is actually a special word for perimeter. It's a special word for a circle, perimeter. Circumference of a circle is the distance around the circle. It's the perimeter of the circle. And then area is the number of square units needed to cover a surface. So those are all of our terms if you need to write those down. We're going to be looking at those. Okay. So looking at a few, here's some of the equations we'll be using as you go down. I've got them all written in front of you, so you can just be looking at them and examining as we look. Triangles, the perimeter is, of course, just adding up all of the outsides. We're adding up B plus C plus D to get our overall perimeter. And area is 1/2 base times height. And whenever we say base times height, these two need to be perpendicular. They must be perpendicular to each other. That's supposed to be an M if you can't tell. Must be perpendicular to each other. I'm not having a good time with my pen here today. Must be perpendicular to each other. There we go. So you'll be looking for this symbol right here when you're looking for them. So they might not be labeled B and H, but you would see something like a triangle, and it might say like 8 units here, and then you might see a measurement that says 3 here. Okay, that would be your base and your height. It would be 1/2 8 times 3. Or you might see a right triangle, and this would be 3 and this would be 5, and then you would know that it would be 1/2 5 times 3. Okay, so they might all appear differently, but that base and height are always going to be perpendicular to each other. Okay, now square. Squares are always the same side length, and they have those 90s in the corner, and the perimeter, of course, is going to have all those side lengths added together, so it's going to be just essentially 4 times one of those side lengths. And area is always, for a rectangle, length times width, and since those sides are the same length, it'll be just side squared, or the side length squared. Now for rectangle, your perimeter is going to be length plus width plus length plus width. Since there's two lengths, we combine those. And there's two widths, we combine those. So it's 2 lengths plus 2 widths. And then your area is length times width. And circumference. That's built off of that term pi. Circumference is 2 times pi times r, r being the radius there. Or knowing that 2 times the radius is the diameter, you could then replace it with diameter, and it's pi d, pi times the diameter. And area is pi r squared. Okay. Now these ones, we do give you the equations for these when you come to the test. However, these, at some point, we expect that you should have these ones memorized. These are kind of base equations. When you get to trapezoids and kites and things like that later on in the material, you might not have those memorized, but these ones you should. All right. Now, things that you can also know. Your distance formula that we learned, you can use that to find the perimeter and the area of a polygon if it's in the coordinate plane. You can also use it to calculate the radius of a circle, and then you could use it to find circumference and area, as long as it's in the coordinate plane. So that distance formula becomes handy once you've got the coordinate plane. And a few more things we can write down here. If we have all sides congruent, we call that an equilateral polygon. Now that comes from this word, the lateral, lats, that means your side, and equal means equal sides, equal sides. Whereas equiangular, that one means equal angles. That has all angles congruent. And then a regular polygon is convex. Convex means all of the angles are facing outwards. None of them are concave, none of them are dented inwards. And they have both equilateral and equiangular sides and angles. So all the angles are the same size, all the sides are the same length. So if we look at, for instance, this guy right there. First of all, they tell us it's a rectangle, but it would not be equilateral because it does not have the same length of sides by appearance, not equal side length or sides, which means it's also not a regular polygon because it does not have equal sides. It is, however, equiangular because it's 90 degrees in the corners. So it's equiangular, but not equilateral. Now, for example 1, it tells us to find the perimeter or circumference and area of each figure. So for rectangle ABCD, we're going to find the perimeter by doing the distance formula of each of the sides. And then once we find the distance formula, we can solve for the perimeter, solve for the area. For circle C, we are going to find the radius from C to D. And once we find the radius, we can solve for the circumference and the area. There you go. So let's see how they do that. There we go. And you can feel free to screenshot this and throw this into your notes, or you can write this down. But for the rectangle, we're going to do the distance formula, and we're going to pick points. So first they picked A and D. And again, with distance formula, it doesn't matter which one is your first point, your second point. They could have changed this around. But they chose A to be the first point and D to be the second point. And they plugged it in. They did their math, and they found it to be square root of 50. And they left it simplified and exact, which is a good plan. So, and we could even write it on there. So square root of 50. And since they said it was a rectangle, we'll write it on both sides. Best plan would be to do it on both sides to know for sure that it's rectangular. Now they're going to go from A to B, and they found out it was square root 32. Square root 32. Now they want to find the perimeter. So the equation is 2 of the length, 2 times plus 2 of the width. So they put that into this equation right here. Now at this point, they just put it in the calculator because this is our final answer. So now it's okay to start approximating. Instead of rounding and rounding and rounding, because if they would have done square root of 50 and rounded that and then added it, and they would have been rounding multiple times. This time they're only rounding once. So they came up with 25.5. The perimeter is about 25.5 units. All right, and then they did area, length times width, put them together, and they got 40. The area is 40 square units. Okay. And they asked, how could you use the coordinate grid to check your answer? Could you go up here and kind of count out?
Watch these students, head on down.
You kind of count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13. Count out and see if it kind of hits around that 40 and see if that's about the best estimate. I think it probably is going to hit there. And the nice thing is that these go straight through the middle, so you're going to hit half boxes too. And you probably get exact for your area. Perimeter is going to be a little bit more iffy, but your area should be spot on. Yeah. Okay, now let's go down here to our circle. We're going to find that radius, and they're going to do that by distance. And they picked their C and D as their x1, y1, x2, y2. They plugged it in, found that this was the square root of 29. Then came down for circumference, it's 2 pi r, so they plugged it in here and put that in the calculator and found that it was about 33.8. And then they plugged it in for area and found it to be about 91.1 square units. There we go. So here is your practice. You are supposed to find the circumference and area of this circle given points C and D. Round to the nearest tenth if necessary. Pause me and do the math. All right, did you find 47.9 units and 182.2 units squared? I hope so. All right, let's go on. Now we're going to model with two-dimensional figures. The fill in the blank here is a geometric model, is a geometric figure that represents a real-world object. A good model shows all the important characteristics of the object it represents, although some of the detail may be lost. Okay? So what that means is we have an object that we want to know information about, and we're going to model it up. We're going to do our best guess, an approximation, using a two-dimensional model. Okay, so we'll show you an example here. Use the appropriate two-dimensional model and the dimensions provided in the image to calculate the perimeter and area of the serving platter. Okay, so we want to know if we've got this platter right here with these beans on it, we know these dimensions, what is the perimeter and area of the serving platter? Now the platter does have dimension to it. You can see that it's got kind of a crevice that goes down into there so that the beans don't just roll right off. So it has a three-dimensional, it's got a third dimension to it. It's got dimension. But we're going to stick in the two dimensions, okay? So perimeter. What do? Well, this one is square. It's a square platter. So for a square, we do this guy, 4 times S. So we do 4 times 12.5, and we find 50 inches. And then the area is the side squared. So you get 156.3 inches squared. Okay. So those are approximations. It's not exact because, again, because there's a divot in there, there's actually probably a little bit more square inches in there than what we estimated, but it's a good estimate. We're modeling that up with an estimate. So now you practice. Use an appropriate two-dimensional model and dimensions provided to calculate perimeter and area of the framed art. So what's the perimeter and area of this frame? Go ahead and pause me and write out the answer. Okay. Did you come up with that it was a rectangle and that the perimeter was 203.2 centimeters with an area of 2,476.6 centimeters squared? All right. Last. Isaiah owns a small cafe. A new fire code states that there must be 15 square feet of free space for every customer in the cafe. How many people can be in the cafe? And Isaiah wants to hang garland around the tables in the drink station. How much garland does he need? So he's made this footprint. He's drawn out grid paper and he's put all of the things in the table and the drink station and the cafe counter. And he wants to find out how many people can be in there and how much garland, okay? So he needs to find out how much free space he's got and how much garland. So he needs to find the total area of cafe. So the area of the cafe first. So he went and said, hey, my cafe is from 0 all the way over to 15 feet here and 0 to 15 feet this direction. So it is a square space, 15 by 15. So it's 225 feet squared. And then he's finding the area of the counter. This guy up here, it's, let's see, 3 feet by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 feet that way. So 3 by 11, which is 33 feet squared. And then the drink station. So this drink station is a triangle. And triangles are 1/2 base times height. So 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5. 5 high, 6 by 5. So that's 1/2, 5 by 6. So that's 1/2 of 30, so 15. So those. And then he's going to take that 225 minus 33 minus 15 to find out what area he's actually got in there. Oh, he's got to find the area of the tables by using the distance formula too. That seems a little funny. I mean, he could just go measure his tables, but since he's got them in at an angle and we've got them on the grids, he's going to go find his distance formula. Since they're matching tables, he's only going to do one. So he did his distance formula on them, and he found out that they are 10 square feet. Okay. And find the amount of free space left. And there's 2 tables, minus there, minus there. Okay, so he did all of that. He took the 225 minus the 33 for the counter, minus the 15 for the drinks, minus 2 of the 10 foots. He's got 157 feet squared free space available. And remember, he needs to have 15 square feet free space for every customer. So that means 157 feet squared times 1 person for every 15 feet squared. These units cancel. 157 divided by 15 is 10.5. And you always round down in these scenarios. You can never round up because code won't allow you to put in more people. So you have to round down. So 10 people. You can have 10 people in the cafe. Okay. The next part was the garland. They need to find how much garland to put around, where was it? Wants to hang garland around the tables in the drink station. So he needed to know perimeter. The garland in the drink station. So he needed to know from here. Oh gosh. I just started erasing all my lines. So purple, I need this and around my tables. Well, we did find the length and the width for my tables right here. So that's good, square root of 20 and square root of 5. Did we have that? Part B. So, got that. Oh, and then the perimeter, we're going around the back side of the drink station too. I didn't realize we could do that. So that was 6 and 5, and then they did that front side of it too, which was that angled. And so they did the distance formula for there. They used the points of it, which were, they used these points right there, 15, 5, and 9, 0. They did the distance formula. There we go. And when they add all of that together, they found that it was 45.6 feet of garland. Okay. So for you, your last one is, if Monica is redesigning her backyard, she has to create the following blueprint to model her design. She wants to have at least 300 square feet of grass available in the backyard for her dog. Is there enough space for her dog? If there is, then how much area is available, yes or no? And if she wants to build a fence in the backyard, she does not want to enclose the edge of the deck that extends from 0, 0 to 30, 0. If she wants to enclose the rest of the backyard, including the side of the edges of the deck and the side edge of the stairs, then how many feet of material are needed to complete the project? Go ahead and solve those. Pause me and come back for the answer. The answer for part A is C, yes, 396.7, and B, 90 feet.